Welcome to Unit 8, Lesson 3, Extreme Value Theorem. This should be a pretty short video. To understand the theorem, let's go over some vocabulary. Maximum means highest, biggest. Minimum means lowest, smallest. For example, let's look at this region. In this interval, the graph is at its highest point here. The graph is going up and then going down. So the point where the graph is at its highest point, that's called the maximum. When the graph comes down, it keeps going down. And then at this point, it goes back up again. So the point where the graph is at the lowest is called a minimum. So maximum, minimum, highest, lowest. So this is what the extreme value theorem says. If a function f of x is continuous in the closed interval a, b. So for example, if the closed interval is 3, 5, then the point 4 is in the closed interval, the point 4.9 is in the closed interval, the point 5 is also in the closed interval 3, 5. But 6 is not. Then f of x must have a maximum and a minimum in that interval. Let's use this graph as an example. Example 1, in the interval 0, 2. Interval 0, 2 means we look at x equals 0 to x equals 2. We look at our graph. Where is the graph at its highest point? Well, from 0 to 2, the graph is at its highest point at x equals 1.816, y equals 3.089. So at the maximum, we have 1.816, 3.089. That's the maximum. In the same interval, the graph is at its lowest point at 0.184, 0.911. So that's the minimum. The extreme value theorem says that there must be some point where it's highest or lowest. Example 2. Same graph, but this time the interval is 1, 2. The closed interval 1 to 2. In this interval, the maximum is still the same maximum, 1.816, 3.089. But the minimum, earlier our minimum was at x equals 0.184, but that's not in our new interval 1, 2. Well, at 1, 2, the lowest point is actually at the beginning. If we're just looking at x equals 1 to x equals 2, right here, well, the graph is at its lowest point at the beginning where x equals 1 is. That's where the minimum is in that interval. I drew that interval in green on the graph. The minimum is right here where x equals 1. That's okay. This is a closed interval. It includes those 2 points. So the minimum is x equals 1. And for this graph, when x equals 1, y equals 1. So in the interval 1, closed interval 1, 2, the maximum is 1.816, 3.089. The minimum is 1, 1. So the maximum and the minimum might depend on interval. Different intervals, different answers. But the extreme value theorem says there's always a maximum and always a minimum. What about this one? F of x equals tangent x. On decimals, the graph looks like this. It's periodic. It means that it looks like a squiggly line that goes up and then goes straight to the bottom and comes up again, and then it goes straight to the bottom and then it comes up again. In the interval 0, the closed interval 0 to pi, it starts at 0, it goes up, 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 and then when x is at pi over 2, the graph makes a jump to negative infinity, and then it comes up again. So in this interval, x equals 0 to x equal pi, what is the maximum? there is no maximum because it goes up forever. It goes to positive infinity as we are coming up from the left as it approaches pi over 2. Like similarly, there's no minimum. If we go from the right towards pi over 2, it goes to negative infinity. So, wait a minute. Does the graph have the maximum in that interval? No. But the extreme value theorem says there's a maximum and there's a minimum. But that's okay, because the extreme value theorem says there's a maximum and a minimum only if the graph is continuous, if the function is continuous in that interval. And f of x equals tangent x. This is the graph of tangent x. Well, f of x is not continuous in the interval 0, pi. So we see that if it's not continuous, it doesn't have to have a maximum and minimum. And the extreme value theorem only says that there is a maximum and a minimum when the function f of x is continuous in the closed interval. So if it's not continuous, it makes a jump, then we might not have a maximum or minimum. Okay, that's it for extreme value theorem.